In this lesson, we will discuss what is DBAL, or Database Access Layer. DBAL is a generalized technology which obscures the underlying database extension. In the case of Doctrine, it's actually a separate project with its own source code tree. What DBAL does is it allows you to write an application which does not have to have an awareness of the actual PHP database extension. This means that you do not have to use vendor-specific commands, and you don't have to use vendor-specific SQL statements, for example. When you write your code relies upon DBAL, which then in turn does the appropriate translation using the appropriate database extension to gain access to the database. DBAL is a separate project within the Doctrine architecture. You'll notice there's Object Relational Mapper and Database Abstraction Layer as separate projects. The Database Abstraction Layer has its own documentation and its own API as well. It supports the major PHP database vendor extensions as well as PDO. PDO is an abstraction layer itself as part of the PHP language. It's interesting to note that the DBAL architecture models that of PDO. For example, in PDO, when you create a PDO instance, it represents the connection. When you execute a statement, it results in a statement object. The statement object can be used in fetching results. Also, PDO supports a series of drivers, just like DBAL. There are 3 different ways of getting a DBAL connection. They all involve the driver manager class. One technique is to use predefined parameters. You would make a static call to get connection from the driver manager instance and specify the parameters with a blank configuration object. Alternatively, you could specify what's referred to as a URL. The URL would include the driver, followed by : // followed by the host, followed by a slash, followed by the name of the database. You would specify this as a parameter called URL. In addition, of course, you would need to supply any additional parameters used by that particular database extension, such as username or password. The third technique is to create a PDO instance directly and supply that as an argument to get connection with a parameter PDO, which is the only requirement for getting a connection using this technique. Let's take a look at some examples. We are now looking at DBAL getConnectionParams.php. We configured Doctrine for autoloading and identified Doctrine DBAL configuration and driver manager as external classes in other namespaces. We then get the parameters from an outside file, database.params.php. These parameters are designed for a MySQL database. They include the host, the database name, the user, the password, and driver-specific options. We then use the driver manager getConnection method to get an instance of a connection. Notice now on line 15 we are now free to generate an SQL statement. In this example, the SQL statement features what's called a placeholder. On line 16, we prepare the statement first and execute it on line 17. The advantage of this approach is that this helps safeguard your SQL statements from SQL injection attacks. The SQL is pre-compiled by the database server with a placeholder reserved for the value. The value is then supplied only during execution. We can then run fetch to get the results. Executing the results, we have a series of values. In this case, the return value is coming back in the form of an array. The array has 12 fields. Each field represents a field in the database. In our second example, the logic is identical, except that we are using the URL approach instead. We build a URL specifying the driver, the host name, and the database name. We also need to supply the username and the password as well. Notice in this example, we are putting the connection command into a try and catch block for better control. We then get the connection using the parameters, again with a blank configuration object. As before, we are now free to generate an SQL statement, prepare, and execute. Another variation in this example is that instead of doing a var dump of the return value, we are accessing direct values from the array, in this case first name and last name. Running the example, you can see we have a list of prospects whose last name is Richards. The third approach, as mentioned before, is using a PDO instance. The file name is DBAL getConnectionPDO.php. We use the DB parameters again to build what is called a DSN, or data source name. This is peculiar to PDO. We specify the driver, MySQL, the host, and the database name in this one single string. We then build a PDO instance using the DSN, along with the parameters for user, password, and driver-specific options. We then get the connection, supplying as an argument only an array with a key of PDO and a value of the PDO instance. Again, we are free to generate an SQL statement and prepare and execute. Running the results, in this example, we've reformatted the output slightly to show last name and then first name. DBAL also supports quite a few other features which are discussed in other lessons. These include the Doctrine Query Builder. You'd simply execute create query builder, which gives you a query builder instance from which you can generate the statement that we've seen before, select star from prospects where last name equals Richards. Notice in this example, the placeholder is a named placeholder, and the value supplied will be a key value pair where the key represents the placeholder name. The file name for this example is DBAL querybuilder.php. And again, the results are identical to the results in the other examples. DBAL also provides transaction support. From the connection, you execute begin transaction. After that, you can run prepare and execute as before. You can then execute commit. If this operation is successful, all commands within the transaction block will be committed to the database. If there's a problem, an exception would be thrown. In the catch block, we can then execute rollback, which would prevent any of the data from going into the database. This prevents database corruption and improves security. DBAL also gives you access to what is called the Schema Manager. You would simply run get Schema Manager from the connection. You can then run various commands, including list table details, list databases, list table columns, list table indexes, etc., etc. DBAL also supports events. Doctrine Common has its own event manager. You can then create an instance of the event manager, add a listener to the event, and supply the event manager as an argument when you run get connection. What happens then is it allows Doctrine to tap into the flow of the application. It allows you to monitor events, in this example, monitoring an event immediately after the connection is established. DBAL also supports caching. You would create an instance of cache and then run set result cache impl, supply the cache instance, create a query cache profile, and then run execute query, after which the query will be cached. So in summary, what is DBAL, or Database Access Layer? It's an abstraction layer which allows you to generate application code which does not have to have specific knowledge of the underlying database extension. It supports such advanced features as caching transactions, using the query builder, prepare and execute, managing events, and also gaining access to the schema.